Today we're going to be looking at factoring by grouping, and this is a technique that works best on polynomials that have 4 terms. It doesn't always work on all of our polynomials with 4 terms, but on some of them it's a good strategy. And we're going to start doing this by using a visual helper. We're going to make a 2x2 box and then put each of the terms from our polynomial into one of the squares of this grid. And it doesn't really matter what order we put them in, but later on it'll be helpful for us if we put the one with the largest degree in this top corner box and the one with the smallest degree, or the constant, down here in the bottom corner. The other two, it really doesn't matter what box we put them in. It'll actually work if you put them in the other boxes, but it's probably best to organize it like this. Once we have our 4 terms put into the 4 places in our box, we're going to look at each of the rows and each of the columns and see what they have in common. So if I look at this top row here at the 10x cubed and the negative 15x squared, they both have a 5 in common, and they each have at least 2 x's, so I'm going to bring those 2 x's out to the side. In the second row, the 14 and the 21 each have a 7 in common. The 21 doesn't have an x, so I can't bring out any x's. Next, I move to the columns. I look at the 10 and the 14. They both have a 2 in common. And x cubed and x, they each have at least 1 x, so I can bring out 1 x. The negative 15 and the negative 21 each have a negative 3 in common. And the x squared doesn't have any other x's to match up with, so I don't bring out any x's. One note about the positive and negative signs. I'd like to bring out the one, this doesn't always work, but I like to bring out the one that's closest to the edge of the box. So this had a negative here, so I like to bring out the negative here, whereas on this one with the 14 and the 21, again, I bring out the one that's closest to the edge of the box, the positive 7. After you've factored, you have an opportunity to be able to check your work by seeing whether the 2 pieces on the outside multiply to the piece that you have on the inside of the box. So we can check our work here by multiplying 5x squared times 2x. 5 times 2 makes 10. X squared times x makes x cubed. Here we can check our work by multiplying our 5x squared by negative 3. 5 times negative 3 is negative 15, x squared. 7 times 2x makes 14x, and 7 times negative 3 makes negative 21. This is a nice way for you to make sure that you're confident moving forward that you've done the factorization correctly. We actually have our answer written now in front of us. This 2x and the minus 3 make one of the terms, and my other term is here on the side. And since this was a positive 7 that these had in common, I can write a plus in between them and write 5x squared plus 7. So I've now factored my polynomial into 2 binomials, 2x minus 3 and 5x squared plus 7. Next, I'd like to look at a circumstance in which I can run into some trouble when I factor by grouping. And that's when items have something in common. So let's take a look at another example. You'll notice as we look at this polynomial that all of the coefficients are divisible by 2. And so the smart thing for us to do at this point would be to factor that 2 out. 2 times x cubed minus 3x squared plus 4x minus 12. Some students might not notice that though, and they might leave it in this term and just go ahead with the factoring by grouping. We want to see what happens when they do that, because they'll run into some trouble if you're not careful. So we'll put the 2x cubed up here in the corner. We'll put the minus 24 down in the bottom right. Doesn't matter where we put the negative 6x squared and the plus 8x. We look at what they have in common. A 2 and a negative 6 both have a 2 in common. X cubed and x squared, they each have at least an x squared. 8 and 24 have an 8 in common. And here's where the difficulty begins. If we look at 2x cubed and 8x, we'll see that they not only have an x in common, but they also have a 2 in common. And negative 6x squared and negative 24 both have a negative 6 in common. But checking my answer, I see that 2x times 2x squared doesn't really equal 2x cubed. 2 times 2 does not equal 2. 2 times 8 does not equal 8. Negative 6 times 8 does not equal negative 24. What's happened is that I've pulled this 2 that everything had in common, all 4 of these terms. I've pulled it out to the left, and I've pulled it out going up. And so I've overrepresented that 2. I've shown it in 2 different places, here and here. So you either need to take the 2 out first, and then factor what's left. So I could factor the x cubed minus 3x squared plus 4x minus 12. X cubed and 3x squared have x squared in common. 4x and negative 12 have 4 in common. X cubed and 4x have just an x in common, and negative 3x squared and negative 12 have a negative 3 in common. Since this was positive 4, I can put a plus here. And now I can write my factorized form with my x minus 3 and my x squared plus 4. And don't forget that we factored a 2 out in the first place, so I need to have my 2 as well. Now what if I made my mistake over here and I didn't initially see that there was a 2 in common? Could I still end up with the correct answer? Yes, if I stop after I've done my first half. So let's take a look at that. Starting out the same way, I can factor out the 2x squared that they have in common, and I can factor out the 8, just as I did before. But now, rather than blindly pulling the stuff out from the top, I can ask myself, what would I multiply by 2x squared to get 2x cubed? And I'll notice I don't need a 2 to multiply by 2. I actually just need a 1. 1 times 2 makes the 2, and x squared, x times x squared makes x cubed. I can double check. 1x times 8 really does make 8x. Over here, to multiply to make negative 6, I need negative 3. Negative 3 times 2 makes negative 6. And I already have the x squared. And then I can check the bottom. Negative 3 times negative 8 is negative 24. So now I have x minus 3 and 2x squared plus 8. At this point, I might be able to notice 2x squared plus 8 isn't prime yet. They both have a 2 in common. I can write that 2 out front. And when I factor a 2 out of here, 2 times x squared makes 2x squared, and 2 times 4 makes 8. And so now I have this in fully factorized form. I have the same exact answer that I had before when I factored out the 2 first, and then factored the remaining stuff using grouping. I end up with the same result if I went straight into the grouping and then realized that I could factor the 2 out.